Hello class, this is section 1.3 and in this video we are going to discuss boundary values for our heat problem. So as a reminder, we have this iron rod laid out horizontally as so, and we say that the x-axis is also horizontal. We want to study how heat travels in this rod. But very often in these problems, we know some information about the ends of the rod, like the left end, the right end, that we can use to narrow down our problem. The first case is known as the prescribed temperature boundary value. In this case, we know exactly what the temperature is on one side of the rod or the other. So for example, we would say that U0T equals 27 Celsius and U10T equals -5 Celsius. Here's an example where this boundary value condition would come into play. Let's say that our rod is the support beam in some freezer room and that the left end is exposed to the outside air, so it's going to be at room temperature, whereas the right end is inside the freezer. And we want to figure out what happens to the temperature in between. So this is an example where we would use the prescribed temperature boundary condition. As a second example, we could consider the insulated boundary. So let's say that we apply rubber on the left end of this iron rod so that heat cannot travel left or right from the left end. In this case, we would say that the temperature never changes from the left end. So partial U, partial x of 0T is equal to 0. So this means that heat cannot travel left or right from the left end of the iron rod. We can also have the right end insulated if we want, or we could have one end insulated and the other end at a prescribed temperature. So these are the most common boundary conditions. There are variations, of course. For instance, sometimes we know that heat is leaking from the left end, but we know exactly at what rate the temperature is dropping. So we could say that the derivative of the left end is -1.